Hello, welcome to the channel where we are reviewing the principles and practices of commercial construction. In this video, we are reviewing the chapter 15 of the textbook, and that is all about roof framing and coverings. So we know that often the exterior profile of a building creates an image in our minds of its intended use. For example, tall spires may imply a place of worship, or a low building with flowing lines can be a gallery or airport terminal. So usually this is how the image is created. So for example, the aesthetic of roof vary depending on architectural requirements, but all roof systems must contain certain basic design elements that will ensure cost-effective performance over a reasonable length of time. Once the building size, use, and location are established, the structural framing, building envelope requirements, and the roof membrane can be selected. So let's move to the second subsection of this chapter, and that is roof design principles. So a basic roof system may be separated into four main areas, and those are building envelope requirements, waterproof membrane selection, structural considerations, and maintenance programs. So, and we know that each plays an important role in the overall performance of the roof. Um, the new materials have been developed for the waterproof membrane, making their application easier and faster. We know that in the recent few years, we have seen many new and tougher materials. Uh, uh, Steep roofs become in many styles and use joists, trusses, or arches to establish their shape. Although the framing of a steep roof may be more complex, the advantage of steep roofs over low slope roofs is that they shed water without the need for integral roof drains. Low slope roofs may require roof drains to facilitate proper draining of the roof surface and to control ponding. Ponding occurs on a roof when insufficient drainage allows water to build up on the roof. And the roof framing system is relatively flexible. The increase in weight due to the excess water produces a sag in the roof that forms a pool of water. And as the weight of water increases, the deflections can become larger until the roof system fails. Ponding can be prevented on low slope roofs by providing a minimum slope to the roof, using more robust framing members, and installing an appropriate number of roof drains placed in the proper locations. So, and you can see there is a section showing the scupper through the parapet wall. Let's move to the next subsection, and that is structural framing for roofs. So we know that structural framing provides support for the non-structural components of roof system, and it must be capable of supporting all gravity loads due to the dead load of all building components. And it needs to include its own weight, mechanical and electrical equipment, loads due to snow and rain, and lateral loads due to earthquakes, and both lateral and uplift loads due to wind. Structural framing for a roof consists of a variety of components depending on the building size, shape, and the building material that is used. So in general, it has primary framing members such as trusses, beams, or girders, then secondary support such as purlins or joists, and some type of roof decking. So we will review each structural component in details. So The division of the roof framing system into its individual components becomes blurred when certain types of materials are selected for the structural frame. Monolithically poured concrete structural frame is one of the examples, and that eliminates the need for roof beams, trusses, and joists. So we can see that when we use different materials, the roof system slightly changes. So let's move to the next subsection, that is truss roof framing. So when a building requires a large open area without partitions or columns, trusses are often used to span the area in question. Large custom designed trusses are normally fabricated using steel or timber sections or a combination of both, although pre-stressed precast concrete sections have been used in truss type configurations. Please refer to the textbook images, as I always recommend back my videos up with the textbook because it's important to see that. And here there is an image showing bowstring trusses with curved glulam top cord. Pre-engineered wood trusses using sawn lumber material are the most popular truss systems used in wood or timber construction. Also, trusses come in a wide variety of shapes and sizes. So we can see here there is an illustration showing the truss configurations, and you can see it can be a king post, W truss, hoe truss, Pratt truss, Fink truss, single warren, scissors truss, hammered beam, cantilever, Baltimore truss, bowstring truss, Belgian truss, sawtooth. So, and please refer to the image and you can see the typical truss components. So we see that on both sides goes the truss support, then the bottom cord, and then the diagonal and vertical elements go together with the top cord. And we can see that distance between the panel point or points is the panel. So that is how the truss is composed. Again, images showing truss plate connection. You can see the arched post-tension welded trusses. And also you can see the section of the steel gusset plate for wood truss joint. Connections in trusses composed of larger sawn timber sections or glulam sections combine steel gusset plates with lag screws, bolt, and timber connectors to transfer the forces at the joints. I also refer to the image showing truss joint using split rings. And also you can see the open web joists serving as purlins between steel trusses. Purlins may be glulam sections, wood eye joists, structural steel shapes, or open web joists. And here is the variation of that shown. And you can see in the residential building, there's the light frame trusses covered with roof sheathing. So that's how it is constructed. Let's move to the next subsection, that's alternative roof framing methods. So when spans are shorter and loads are lighter, a variety of roof framing alternatives have been developed to the large trusses. This framing systems using wood, steel, and pre-stressed precast concrete sections have been developed to maximize efficiency in design and construction. So for example, open web joist roof framing. That's an alternative to the heavy truss purlin framing. And these light pre-engineered sections, commonly known as open web joists, provide a cost-effective approach to roof framing. They are used primarily in low slope or flat roofs. Open web joists are used in a wide array of framing schemes, and you can see how that is used here. Please refer back to the graphics. The main difference between these lightweight trusses and regular trusses is that open web joists come in standard depth and length and are manufactured on an assembly line basis. Open web joists are normally designed using horizontal parallel top and bottom chords connected by rod or tubular steel webs. Two types are generally manufactured, and that's open web steel joists and open web combination joists, in which the cords are of sawn lumber and the webs are of tubular steel. There are usually catalogs of the load capacities that the manufacturers list on their websites or in the special catalogs. So, and also erection drawings and details are provided to the construction site to ensure that the joists are properly installed. So you can see there are many images showing that. Combination joists span 50 feet with single top and bottom chords on the flat with double top and bottom chords on edge, for example. A wooden pad on the bearing surface of the support simplifies the anchoring of this type of joist. Roof overhangs may be incorporated into the system by using web joists with ends that project or cantilever beyond the outside bearing member. And you can see there is an image showing that. So structural steel roof framing. Industrial buildings that may have large openings in their roofs and support heavy equipment use rolled structural steel shapes for the roof framing. Hot rolled wide flange sections, channel shapes, eye-shaped sections, and light wide flange sections are used as framing members. The shape and size of section used are based on loads and spans, so that will vary from building to building. In pre-engineered rigid frame steel buildings, cold rolled C or Z sections are used as the intermediate framing members. The thickness of material for these shapes ranges from 10 to 16 gauge to expedite the cold rolling process. A typical connection detail is actually shown here, so please refer to the textbook and you can see that. Timber roof framing, let's talk about that. Sawn timber beam sections used as roof framing are normally used where loads and spans are relatively short. When greater spans between supporting beams are required and the sawn timber sections are no longer efficient as intermediate roof framing members, joists are used as secondary framing members to support the roof decking. Joists can be sawn lumber sections when relatively short spans 4 to 15 feet are anticipated. The use of eye-shaped manufactured sections for spans 16 to 30 feet is becoming more common. Regular plywood sheathing is used as decking, and then the joists are usually spaced 16 to 24 inches on center. And again, please refer to the images. You can see the glulam roof girder that supports roof trusses and eye-shaped wood joists at 24 inches on center. So let's move to the precast concrete roof framing systems. And they consist of beams and joists and are used primarily in warehouse type structures where spans are repetitive, allowing for a large number of similar sections. The use of steel decking to spans between the joists, much like in a structural steel building frame, is common. So single T and double T sections, because of their properties, are most common in roof applications where longer spans are needed. So please refer back to the images. You can see there is a pre-stressed precast concrete joists. That is actually followed by the pre-stressed precast concrete roof system. You can see how that is connected. And also you can see the pre-stressed beam supporting pre-stressed roof joists. Also, there is a chart showing typical pre-stressed beam sizes in inches for concrete joist system. You don't have to remember that, but you need to know where to find information when you need that. So flange widths range from 4 to 10 feet, although the 8 feet sections is most commonly used. Depth range from 12 to 48 inches, with the 36-inch depth being the popular ones. And here you can see another chart showing typical pre-stressed beam sizes for single T slab system. And also there is a section showing that. The next one is double T roof slab, and they are probably the most widely used pre-stressed concrete products in the medium span range of buildings. So they are available in various widths and depths, depending on the manufacturer. So please refer to the images. And again, there is another chart showing typical pre-stressed beam sizes for double T slab system. The next one is cord slabs, and that's that the production of hollow core slabs is highly mechanized, and their cost is relatively low. Cord slabs are quick and easy to install and provide a finished flush ceiling, and they may be used with almost any type of framing system, including pre-stressed edge and interior beams. So again, please see the core slab roof system, as well as the typical pre-stressed beam sizes for cord slab roof. Again, nothing to memorize, but you need to know where to find that information. We are moving to the next subsection, and that is roof framing systems and roof styles. Many structures, for example, such as the Sydney Opera House in Sydney, Australia, have become world famous, and that is totally because of its roof and that shell-shaped curved roof lines. One of the advantages of a roof framing system is that it combines lightweight materials such as plywood sheathing and low sawn lumber into build-up sections and can span greater distances using less materials. So let's take a look at the stressed skin panel roof systems. They are composite sections made up of plywood panels as flanges and 2-inch nominal sawn lumber plank sections as webs. So please refer to the images here. Folded plate roof systems. That is one of which the roof slab has been formed into a thin self-supporting structure and usually made of either wood or concrete. Two of the most common shapes are W shape and V shape, and you can see it here. There is a section showing that. The style of roof is being used more and more to provide large areas of column-free space. Such roofs are capable of long spans, and their cantilever projections can be used to advantage in exterior design, as well as to counterbalance this span. Also, here you can see the section showing form for concrete folded plate, how that is created, and span data for W-shaped folded plate. So again, nothing to memorize, but you need to know that that is there, and it's also available for the V-shaped folded plate. A wood folded plate roof is made up of panels bolted together to form a complete roof structure. So here you can see another section showing that. And also you can see the prefabricated wooden roof panel. So let's talk about long barrel shell roof systems. Um, so that is a curved thin shell roof normally made from concrete or wood, and the shape of the curve can range from a low rise arch to a high rise circular arch. Roof systems of this style provide long uncluttered spans that compare with truss framed roofing systems, as well as adding unique architectural features. You can see how that is created. You can see undulating barrels. You can see barrels with stems, parabolic barrels, as well as the cylindrical barrels. Another chart showing span data for concrete long barrel roof shells. And we're moving to the dome shells. Rotating an arch profile 360 degrees about a vertical axis through its apex creates the dome surface. Because all elements of an arch are in compression, an arch shape is a very efficient structure, provided that the resulting horizontal truss at its base is resisted either by a tension tie or by the foundation. For a dome shell that is supported on columns or walls, a tension ring at the base of the shell absorbs the horizontal force. With all forces in the shell being compressive forces, the concrete shell can be relatively thin. So please refer to the chart showing span data for dome shell roofs. And you can see the section showing how that is connected to the tension ring. So when we talk about hyperbolic paraboloid saddle-shaped roof systems, we need to remember that it is a structural slab that attains its strength and rigidity by curving it in space in two directions. Originally, these types of roofs were constructed using reinforced concrete, but as with concrete domes, the formwork is rather complex. Because of the doubly curved surface, the formwork sheathing is required to twist, and large sheets such as plywood make compliance to the required shape difficult. So to counteract this difficulty, narrow board strips have been used as formwork sheathing. This alternative, although viable, is rather labor intensive. So again, please refer back to the images. You can see the roof frame with cables. You can see foamed plastic and concrete surface. And also you can see the span data for concrete hyperbolic paraboloid shell roofs. So please refer to the images and always back up the videos with that. And there are also sections here, and you can see the sports arena with cable supported roof and support cables in place for cable supported roof. So let's move to the next section, and that is the roof decks. So the roof deck provides support for non-structural elements of the roof, which normally include the insulation, air barrier, and waterproof membrane. Lighting fixtures are often attached directly to the underside of the deck, as can be in some instances hangers for a suspended ceiling. The load capacity and the span of the deck between supports are determined by the physical properties of the deck material and the deck profile. The basic construction materials, wood, concrete, steel, gypsum, and lightweight cellular concrete, are viable as roof decking. So let's take a look at the wood decking. Two types of wood decking are available for roof construction, and they are solid wood decking and manufactured wood sheet decking. The latter is available as plywood, OSB, and wafer board. Typically, only plywood and OSB are span rated for structural construction. Manufactured wood sheets are normally used in conjunction with light truss framing or roof joists spaced not more than 24 inches on center. Solid wood decking may be constructed of planks laid on the flat or 2-inch material laminated on edge. Planks put down on the flat are usually tongue and groove and often are left exposed to serve as the finished ceiling. So again, please refer to the images. You can see the plank decking on supporting purlins. Concrete roof decking. Concrete roof decks may be poured in place structural slabs or precast sections using normal weight or lightweight concrete. Concrete roof decks are used where traffic load is high, such as rooftop parking areas. Hollow core precast sections can be used to advantage by eliminating the need for on-site formwork. Insulation and waterproof membranes can be easily applied without the need for any additional framing. Steel roof decking is used in conjunction with wood, precast concrete, or steel framing. Although deck profiles can vary depending on the manufacturer, steel decking is available in 1.5-inch and 3-inch depth. It is normally available in 16, 18, 20, and 22 gauge thickness. So please again refer to the images here. Gypsum roof decking. Gypsum decks are made from poured-in-place gypsum or precast gypsum planks. In using poured-in-place gypsum, structural steel bulb T sections spaced 33 inches on center serve as supports for 32-inch wide, half-inch thick gypsum board sheathing that is placed between the T-webs to serve as the bottom of the form. Please again refer to the sections shown here. And we are moving to the final subsection of the chapter, and that is roof membranes and insulation. The essential element of any roof system is the waterproof membrane. Although its location within the roofing system may vary, its prime purpose is to provide continued protection to the underlying components of the building over a wide range of climatic conditions. To achieve this, the membrane must be durable and physically and chemically stable, and it must resist the effects of the sun's ultraviolet rays and remain flexible. It must also be compatible with the associated insulation and the supporting decking material. To ensure a lasting and watertight installation, quality control or QC and proper workmanship during the placement of the membrane are of utmost importance. Many types of roofing membranes are available, and the selection depends on a number of factors. These factors include: one, the suitability of the membrane material, including cost for the shape of the roof structure. Two, the necessity, location, and type of vapor barrier. Three, the characteristics of the particular insulation. Four, the thermal characteristics and rigidity of the decking material. Five, the required durability of the roofing membrane. Six, fire resistance of the roofing. And seven, the aesthetic value of the roofing material. So let's take a look at the sheet metal roofing. That is a popular choice as a roofing membrane because of its durability and ease of installation. In many applications, metal roofing eliminates the need for decking. Um, in that, its ribbed profile allows it to span from joist to joist or purlin to purlin. Manufacturers have devised methods to secure the sheet metal to the supporting substrate to resist uplift forces due to wind. And in some retrofit applications, corrugated metal panels are used in replacing asbestos roofing panels. There are three basic shapes made available, and that is corrugated, ribbed, and flat. Corrugated panels normally have a rather low wavy profile that ranges 1/4 inch to 1 inch in height. Ribbed panels come in many different profiles depending on the manufacturer, and rib heights range from 1 inch to 1.5 inch. And wood or steel purlin supporting ribbed or corrugated metal roofing must be spaced accordingly to the gauge of the decking material and the superimposed design load. Again, refer to the chart showing maximum permissible purlin spacing for galvanized corrugated sheet metal. Also, you can see the typical metal roofing profiles, and you can see the corrugated metal roof panel, ribbed metal roof panel, and standing rib flat panel. Also, there is a section showing corrugated roofing over steel purlins, and you can see the standing rib metal roof membrane application and the residential structure. So the selection of a seam type is determined by architectural requirements, slope of the roof, or roof exposure conditions. Seams can be factory formed, snap type with or without factory applied adhesives, or be field crimped. Special self-centered clips to allow for expansion and contraction are attached to the supporting substrate at intervals along each rib to hold the panels in place. So again, please refer to the images. You can see the standing rib seams, and you can see the soldered seam for sheet metal roofing, as well as the sheet laying order, how that is designed. Asbestos cement roofing. It is restricted now in many countries due to adverse effects on human health. Certain products, including asbestos cement sheathing, corrugated and flat, and asbestos cement pipe, are still being manufactured and used. Such products are no longer manufactured in the US, and their use, considering the public's perspective on asbestos and its dangers, has essentially ceased in the US. So the most common application was on industrial buildings, such as those in mining operations and as roofing and siding for many single-family residences. The most popular brand name of such panels was Transit. Here you can see asbestos cement roofing sheets, how that was connected. There are sections and also diagrams showing that. Built-up roofing. Built-up roofing membranes until recent times have been the choice of designers for low-slope roof applications. This type of roofing membrane consists of layers of roofing felts bonded with coal tar or asphalt, resulting in a flexible monolithic waterproof layer. It is laid down to confront and bond to the roof deck, and it must provide a seal around all projections and openings in the roof. The membrane is turned up at vertical surfaces such as walls and skylight curbs as base flashing. You can see the flashing at parapet walls. You can see all the details here. You can see the parapet design constructed of the CMU blocks. Then you can see the waterproof metal cap covered on both sides with foam rod. Then there is a through wall counter flashing. Then there is a backing, metal strip flashing, cant strip, base flashing, and built up roof on insulation. And underneath, you can see void blocking and grout, as well as the precast hollow core roof slab that everything lays on top. Also, there is another section showing flashing at roof edge. Insulation and air vapor retarders are a part of most built-up roofing installations. The proper design and installation of a vapor retarder are particularly important in northern regions. Without it, moisture vapor from within the building will penetrate the insulation, condense, destroy the insulating value, and eventually result in blistering or other damage to the roof covering. The vapor retarder may be located at various points at the roof assembly depending on the type of construction. It may be over a suspended ceiling, under the roof deck, or most commonly over the roof deck just under the insulation. The insulation is sometimes completely enveloped in vapor retardant wrapping, in which case the joints between insulation boards must be adequately sealed. Vapor retarders or barriers are not used in warm weather applications and, in fact, would be detrimental to the roof system if they are installed. Insulation is installed over the vapor retarder or over the deck by mechanical fastening or by cementing it with asphalt or other adhesives. Roof deck insulation is commonly of the rigid board type and may be rigid urethane, glass fiber board, cork board, expanded polystyrene, or wood fiber board. Roof deck insulation may also be cast in place using lightweight insulating concrete, a mixture of vermiculite or perlite aggregate, air entrainment, and Portland cement, or cellular concrete consisting of Portland cement and a foaming agent. Before modern single-ply and two-ply roofing membranes were in common use, two standard specifications were developed for built-up membranes. One, a 5-ply membrane for wood decks, and two, a 4-ply membrane for concrete decks. And the basic difference between a 5-ply and a 4-ply membrane is that the 5-ply has sheathing paper and two piles of dry felt nailed to the deck prior to the application of the remaining layers. You can see there is an image showing that. Many types of built-up roofing membranes or hybrid built-up membranes are generally available depending on the types of felt and bitumen used. The first one is asphalt saturated organic felts, asphalt and gravel. The second one is coal tar saturated organic felts, coal tar pitch and gravel. The third one is asphalt impregnated glass fiber felts, asphalt and asphalt flood coat. Then the fourth one is asphalt impregnated glass fiber felts, asphalt and gravel surfacing. Then asphalt impregnated glass fiber felts, asphalt and modified bitumen cap sheet surfacing. Then styrene butadiene styrene or ASBS modified bitumen felts fully mobbed in hot asphalt. And the last one is actactic polypropylene or APP modified bitumen felts torch applied. So there are many combinations of these materials, and they will depend on the expected condition at the job site. The following construction conditions may apply, and that is For example, the structural roof frame is open web, steel joists supported by beams and a perimeter load-bearing wall. Then it can be a roof deck with corrugated galvanized steel decking, and the insulation will be one layer or of 2-inch thick polyiso foam or isoboard insulation, followed by one layer of 1-inch thick perlite insulation board. So it totally varies, and the application can be different. Modified bitumen materials. Modified bitumen is a term applied to conventional roof and asphalt that has been modified by the addition of polymer chains to achieve a material with better properties than conventional asphalt alone. In particular, the modification produces a material that has much better tensile strength and stretchability, and these are commonly called rubberized asphalts. So let's take a look at the bitumens, and there are generally two bituminous materials used in built-up roofing. These are asphalt and coal tar or pitch. Coal tar has superior waterproofing ability over asphalt, but is more difficult to work with in two respects. So it produces strong fumes when heated, and coal tar cannot typically be installed on any slope greater than 1/4 inch per foot. So it will start to flow downhill as roof temperature approaches about 140 Fahrenheit. So note, steep roofs are not good for this application. There are 4 types that correspond to the temperatures. Type 1 up to 151 Fahrenheit, type 2 up to 176, type 3 up to 205, and type 4 up to 225 Fahrenheit. Protected membrane roofs. In a conventional built-up roof, the waterproof membrane, usually composed of felts and bitumen, is placed on the outer surface of the insulation. It is then covered with a layer of gravel or slag for protection. With the membrane so near the outer surface of the roof system, it must be able to resist all the stresses exerted on by temperature changes, weather changes, traffic-related loads as well. So here you can see the section showing protected membrane roof on concrete and steel roof decking. So please take a look at that when you have a chance. With so the advantages of this application are, we have discussed the advantages of this application, and there are also some disadvantages. So the insulation must be able to withstand the effects of the weather and traffic-related loads, and a number of different insulations have been used, such as rigid type insulations, glass foam, urethane foam, glass fiber, cork, perlite fiber, and so on. The one drawback of polystyrene insulation is that it must be protected from the effects of ultraviolet rays. Also, you can see the patio blocks used as insulation protection here on the roof. And we are moving to the single ply roof membranes. The leading concern in roofing design is the ability of the waterproof membrane to resist the effects of the weather over an extended period of time, while still retaining its water resistance. Until recently, the built-up felt and asphalt roof membrane was the only practical means of obtaining a waterproof barrier on low slope or flat roofs. As a waterproof membrane, its success depends largely on the quality of the workmanship during placement rather than the quality of the materials used. So in the roofing industry, excuse me, single ply membranes are divided into two basic categories: thermoset materials and thermoplastic materials. Thermoset membranes consist of rubber polymers and are commonly known as rubber roofing. The most common is EPDM, or ethylene propylene diene monomer. Thermoplastic membranes are composed of plastic polymers. The most common is PVC. So this type of membrane can be reinforced with glass or polyester fibers to further increase its strength and stability. And again, refer to the images. You can see the mechanically fastened single ply roof membrane, as well as the self-adherent vinyl membrane used on a curved roof. You can see the application here. So monoform roofing, what is that? Let's take a look at that type. That is a reinforced asphaltic membrane that is applied to a roof with a special type or spray applicator. The membrane consists of a specially formulated asphalt compound reinforced with glass fibers. You can see that, and you can see how that is applied. And um, also, let's take a look at the fluid applied roofing membrane. And that is usually either an acrylic compound or a urethane-based material, available either clear or in a range of colors. It is sprayed on in enough applications to build up a 15 to 40 ml dry film that is impervious to moisture and humidity, flexible and elastic through a wide range of temperatures. Fabric roofs, they have been used as temporary structures, and early fabrics were used of natural materials and had strength and durability limitations. And you can see there is a picture showing the inside of the world's largest air-supported fabric roof stadiums. The fabric is usually of a polyester, nylon, or fiberglass base coated with a polymer, vinyl, or silicone to produce an extremely strong, durable, and waterproof material. The use of additional liners produces insulation values that are comparable to conventional roofing systems. Many of the fabrics are translucent, allowing sunlight to pass through them, reducing the need for artificial lighting, yet replacing much of the sun's radiated heat. Two basic methods have been developed to support fabric roofs, and that is cable suspended roofs and air supported roofs. Cable supported roofs depend on a structural frame from which which the roof cables are suspended and over which a fabric is stretched. You can see an image here showing the aquatic center covered with a fabric roof supported by a reinforced concrete arch. In the case of an air-supported structure, large blowers or fans provide sufficient positive pressure inside the building to support the roof structure. Steel cables are usually placed over the fabric in a checkered fashion to provide stability for the envelope during high winds. And you can see there is another image showing that. Let's move to the final little subsection, and that is green roofs. With changing climate conditions and high energy costs, an age-old roofing system concept termed a green roof is being revived. The concept is very straightforward. So a layer of soil is placed on top of a flat or low slope roof and seeds are added. With a little water and fertilizer, in a very short time, you will have a green roof. If grass is planted, a goat can be added to the grass that is trimmed and naturally fertilized. Although the goat may be not practical in many cases, the concept of a green roof certainly has merit. So you can see that application in many countries, and the concept of a modern green roof has been revitalized by environmental conscious individuals and by organizations, for example, such as the USGBC or US Green Building Council. A typical cross section of a roof, of a green roof, is very similar to an ordinary roof. So there is a structural frame supporting the deck covered with air retarders, insulation, and a waterproof membrane. Then superimposed on the roofing system is a growing medium such as soil, a filtering membrane, and a drainage layer to drain away excess of water that is not required by the plants. And you can see here there is a section showing that. So some indirect benefits to the of the use of the green roof are as follows: new opportunities for contractors, landscapers, and product manufacturers. Then reduction in the urban heat island effect, improved air quality, improved storm water runoff mitigation. And this wraps up our our chapter 15. Thank you so much for watching. I will see you in chapter 16.